Hi, I'm Billy from Greenwood Solutions. Today's presentation is on kilowatt hours, electrical basis. What does it actually mean? What are you paying for on your electricity bill? We're going to look at service charges, consumption charges and demand charges. We're going to be looking at electrical basics, kilowatt hour. What does it mean? What energy loads does a site experience? What types of energy are we talking about? What are you actually paying for on an electricity bill? Renewable energy and site loads, the connection. How much are you spending on electricity now? What energy management strategies are available? How do you assess your actual loads? How to maintain productive process but also reduce costs, really important. And steps to create an energy management strategy. A kilowatt hour, it's a measure of energy, and it's important as this is what you pay for on your electricity bill and has a time constraint. For example, a 1,000 watt load on, in other words, you've switched it on, for 1 hour is 1 kilowatt hour of energy used. So when we talk about kilowatt hours, we're talking about energy. Power is instantaneous. In other words, I have a 1,000 watt load. And when I say a load, I mean an appliance. So in someone's residence, it might be a kettle, it might be a TV. In a commercial setting, it might be a 3-phase welding machine. It could be the motor driving a conveyor belt. That is what is called a load. So residential, appliance equals load. Commercial, anything that is electrically driven is a load. Now let's look at an example. We have an irrigation pump. This is a nursery situation. It has a power rating of 1,000 watts. It is on for 6 hours per day. So this has used 6 kilowatt hours of energy. 6 kilowatt hours is how much energy is consumed. On your bill, you pay, for example, 25 cents per kilowatt hour. So to run the 1,000 watt pump for 6 hours costs $1.50. 6 times 25 cents. Now we have another example of a cold storage facility of about 1,200 cubic metres. Now it takes 0.75 kilowatt hours per day to cool 1 cubic metre of this facility. And in this situation, the total kilowatt hours used per day is 900. 900 kilowatt hours a day is how much energy is consumed. On your bill, you pay, for example, 25 cents per kilowatt hour. Cost to run per day, for this example, is $225. This equates to $82,125 every year, a substantial amount. There's a service charge, and we all get those. There's a consumption charge, in other words, how much we use, and there's also a demand charge. The service charge is a fixed charge, not related to how much electricity is consumed on site. And a commercial solar system can't directly negate this cost. Price per kilowatt hour of energy used can be different prices at different times. For example, price during the weekend may be different from price on the weekend. Demand charge, also known as a capacity charge, a daily charge determined by the highest power demand or load observed during a certain time frame and during the day in a specified period. So whether you're a cold storage facility or a nursery or an engineering company, you have a consumption profile. And if you have a consumption profile, then you can implement energy management strategies. Now, obviously, you cannot introduce a strategy that reduces your ability or affects the productive process in a negative way. That's just silly. But what you can do is look carefully at what you can change to reduce your consumption and maybe affect also the demand charge side of things. For example, there's an engineering company we looked at that basically the person who came in the morning at 7 o'clock just turned on all the machines. There's 6 of them, just went bang, 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 and those machines are up and running. When in reality, he could have turned them on sequentially because the 5th machine wasn't used till about 9:30, 10 o'clock. But he, as a matter of habit, he was just turning them on. And this incurred a demand charge which upped their electricity bill considerably. So a simple change in habit allowed this business to actually reduce their demand charges and save a bit of money in the process without any detrimental effect on their ability to make money. So it's something it's quite a simple approach, but it's something as a business owner you can do. What energy loads does a site experience? Usually two main types: electrical loads, office loads, site loads, and gas, natural or LPG, office heating, hot water, etc. So what steps are needed to create an energy management strategy? Well, the first thing is to identify all site loads, segregate into categories, electrical and non-electrical. Further divide into site-specific loads and office loads, non-specific. You can look at a full energy audit of the site, look at the installation of a renewable energy system, and look at possibly more comprehensive site management software if that's an option. Obviously, cost-benefit analysis is required. The most effective energy management strategy is really adopting a commercial solar system. And by adopting, I mean looking at and investing the time and energy to understand what a commercial solar system can do for the bottom line of the business. Because at the end of the day, we have this giant ball of sun pumping out energy, which we can capture with modern day technology being solar panels at a very economically viable price. It really is a no-brainer in this day and age. If you've got a big roof area and you've got a predominantly daytime load, solar really is the option. During winter, you can set the heating temperature lower. During summer, you can set the cooling temperature higher and look at phantom loads in office and reduce. With office air conditioning, the recommended summer temperature is between 26 and 27 degrees in southeast New South Wales, Victoria and the ACT. Recommended winter temperature is 20 degrees. Outside these temperatures, you can really increase your costs. A 1 degree drop in summer temperature results in a 10% increase in cost. This can add up with multiple air conditioners. The perceived level of thermal comfort from the perspective of the employees must be taken into consideration when implementing any of these energy management strategies. You don't want a situation where the employees are going, it's too bloody hot, it's too bloody cold. From the previous example, let's say we have an air conditioner in the office. The cooling capacity of this air conditioner is 6 kilowatt, and in summer it's running for 8 hours a day. So 8 hours at 33 cents per hour times 365, that's $963 a year. If we run at 21 degrees, cost per hour increases to 50 cents. So 8 times 50 cents times 365 is $1,460 a year. This is an increase of 51%. Let's say there's 5 of these air conditioners all running 8 hours a day. If we run at 21 degrees, this cost per year is $7,300. If we run at 25 degrees, cost per year is $4,818. Average daily load of the site is available from the bill. The site's interval data is available from the retailer. Installed site-specific metering can be looked at, and other monitoring equipment. Interval data, what is it? It is multiple snapshots of energy consumption on site, usually in half-hour increments if obtained from your smart meter. It shows what's being consumed at 8 p.m. and 4:30 a.m, for example. Interval data, why is it important? This is because getting a commercial solar system for your business is mainly based on financial considerations. If you're saving energy at a cost of 25 cents per kilowatt hour, you don't really want to sell excess at, say, 9 cents a kilowatt hour. By analysing the interval data, the commercial solar system designer can come up with the best system financially. Conclusion. A kilowatt hour is a measure of energy. 1 kilowatt hour equals a 1,000 watt load on for 1 hour. You are charged a service charge, a consumption charge and demand charge on your bill. With your energy management strategy, segregate loads into different categories. When you use electricity is as important as how much electricity you use. Thanks for watching this week's presentation on kilowatt hours, electrical basics and what it all means. If you have any questions, any inquiries, any answers, please feel free to drop us a line and hit that subscription button if you see fit. Thanks guys, bye.